Hello, everyone. Welcome to the Agentic AI workshop, and we're going to talk today through uh, Jaseci, how to use Jaseci to build Agentic AI. And first of all, I want to check out like how are you guys doing? You guys are participating in this hackathon, and you guys are building amazing things. Uh, so first of all, I really appreciate you guys putting your effort into these projects, and let's see how it goes in this by the end of this hackathon, how you guys are doing. And yeah, so get right into our workshop on agentic AI. So first of all, Jaseki is a language that's built for full stack application development. It's not just for agentic AI. It's not just for full stack. It's not just for backend. It's for the entire thing. So one man can build the entire application from front end to back end to agentic AI. So that's the thesis of Jaseki and Jack. So, before getting into agentic AI, let me quickly walk through how like the code looks like when it comes to building these front full stack applications. So the best way to understand that is let me just move to the best place to understand this is through the tutorial that we offer in the documentation. So before jumping into that, so we basically for full stack. We don't need glue code to like bind the back end and the front end, which you have to do when you build like front ends and back ends separately. And you AI is like a native thing in the language itself, so you don't have to prompt at all. And that's agentic AI, how you do agentic AI with Jack. So i- it's a very crazy tech. And then again, you can deploy to Kubernetes like this. Just do one command and it's up. So, first of all, let me just go through the building and learning AI day planner. So that's the tutorial that you should look at if you want to build a full stack application. And it goes through the everything there is to building this application. And if you need more information like how to do multi-user, and multi-user is of course there. How to do collaboration between multi-users. That information is embedded in this full reference. And if ever you are in a pickle, go to you can quickly go to yeah, let me see. Okay, ChatGPT. And you can go search ChatGPT and just ask questions about the documentation. You can just ask questions here. You can use there's an MCP server, there's a RAG system, or both. You can just play around if you want to, and search for anything that you need to understand about something like this. Yeah, some of my recent chats. Cool. So ChatGPT is there if you need, but more than ChatGPT. Uh, what I would really like you guys to do is go to this Jack Builder. So I think Jason like showed you guys how Jack Builder like looks like. So if you go to Jack Builder and I'll just go, just let me play. I think I have a GitHub account, as I remember. Yep, there I'm in. So use the Jack GPT and you have a Jack coder, which is really good at like learning Jack, using Jack, and that's I think where the key place you should look at. And yeah, so let quickly get into the tutorial and look quickly through it, and then get on to like building hands on how to use the tools that's available in Jaseki. So in Jack, you basically can build like the front end and back end application directly. Let me just uh, go to the GitHub itself so you can see the examples. So you can go to Jack. Let me see. Give me a second. There you go. Just get the link directly. There you go. Okay, so this is the day planner. It's the fully built one. It's actually available in the repo, so you can go in there, grab that code, and look at it, or else go through the tutorial. Either way, so you have this. So you can see in front end seal. So if you go to the main.jack, yes. So here is your main application code where everything starts. And you can see that there's some different things at the bottom or the header of this application, which is 2CL. And then you write import from front end, blah, 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 and to SV, and you do this. So this is basically what this does. This code does is it can compile down to front end and back end. So SV means server side or back end, and then you have CL or client side or front end. So everything that here you basically import from front end app as like client app, you import the client app, and then import the app and just do return client app and call it a day. So that's the front end, and then you write the entire backend with AI functionality right here. So this is a AI functionality right here, which does a categorization using this enumeration available here category, using this enum, work, personal, shopping, health, fitness, other, is going to categorize any title into any of these categories. It's signified by the output type. So this is the only thing that you have to do. But if you want to pass in a little bit more information, like, okay, categorize a task based on its title. You can add something like this. This is called a sem string or a sem annotation. It's a semantic annotation. That's why we call it a sem annotation. So you can do that and enhance your AI to know what it needs to do. But to get a bare bones thing done, you don't need a sim string at all. The function signature itself is the AI's prompt. So that's called by LLM. So this is the by LLM plugin that's built for Jaseci, part of the Jaseci ecosystem. It's a by LLM plugin built into the Jack language, and you just have the syntax by LLM. So yeah, okay. So and the front end code just look like this, and you have def pub and JSX element, and you just write your front end code here. So you can write the front end code, the back end code. In theory, you can write it everything in one file, but it's good to like separate. So separate files, but import. Then import, and you can see this function being called like if you go to main, you saw this categorize function, and if you look at the front end, you'll find that you have functions like to column container. Yeah. So you can basically import any function and call it, and the runtime manages the actual connection between the front end and the back end. So yeah, now, so this is just to give you a preview of what you can build with Jaseki. So now let's actually go into the actual tutorial and go through, talk you through how by LLM can be used to build your applications, full stack applications. Yeah, so let's switch gears right now. And okay, so for the agentic AI workflow workshop, first of all, we should think about what is agentic AI and AI agents. It's kind of one of the same thing, but the how I define it is a program that exhibits agency versus a system that orchestrates an AI agent. So, and when you have an AI agent that can have the agency to use tools, not to use skills, not to use skills, decide what to do for themselves, we call them agentic. While agentic AI is basically a system of orchestration among these set of agents. So, the key challenges when building these agents, if you have ever tried, is two main things. One thing is prompting or writing the prompts, writing the skills. That's a specific skill, and that skill is also specialized for one type of model. Let's say you are programming for an anthropic model, and you switch models to some, let's say, a Gemma model that's running locally, and you have to change your prompting strategy a little bit. So there are a lot of intricacies there that gives you a lot of pain when you want to switch from here to there, switch the model. So that's one pain, and prompt engineering has been a pain for a while. But recently, agent orchestration has been a big thing, and everybody's trying to scramble at building their own agent orchestration. You might have seen OpenClaw, Hermes. All of these are doing agent orchestration, and are they call we, some call it a harness, sort of agent harness. So you have agent orchestration or harness that's built to run this agent in a way that's useful for a human. The way Jack helps you build solve the prompting problem is by basically removing that layer entirely and replacing it with a function definition or a function's declaration signature. So if you say def answer a q string and output string, that means at the by LLM at the end, that means there is an LLM in the program and you are delegating this function to an LLM, and the LLM just returns the output. It does not generate any code. It doesn't run any code. It just calls the LLM, get the thing done on the LLM side, and bring back the result as a string. That's the basic abstraction that we introduce. Of course, it's not just strings. We'll get to that in a bit. Like it can do a lot more than just strings. But yeah, that's the bi-LLM piece right there. And the other piece is the object spatial programming. We'll go in a little bit into that as well. It's a new concept like object. So you have object oriented programming. So this is object spatial programming, which is a augmented version of object oriented programming, where you can have relationships between objects, and that it makes it a key way that we can use this programming model to build agents. So more on that later. So let's look into challenge one, prompt engineering. So previously, when you build your applications, you have these kind of types. So let's say we have a game level generator and you have these types in your program. You want to use these types and like generate a map and represent that map using these types. However, it's going to be a hard task if you are doing prompt engineering where you have to convert them back to the type, which Pydantic kind of allows you to do it, but still there's a lot of like error handling you have to do and parsing that Pydantic model. Now you have like double defining the same thing, or you have to basically embrace the entire Pydantic ecosystem just to do a simple thing. So why don't we just abstract away this complexity? Because prompt engineering is a lot of complexity right here. As like I just talked to you, I won't go through it again because it on itself is 147 lines. So let's skip that for a bit. And so it introduces a lot of complexity. So the problem is this is a lot of work. How can we abstract that away? So again, we have to think about when these languages were invented and why these libraries exist, like DSPY or any other SDK that lets you do agents. So these libraries exist because these languages were never designed with a focus of building agents at all. So people build libraries around this. Uh, non-existing capability so you can give the language more capability. So the same with SDKs. TypeScript have this AI SDK that was built because everybody's building agents. Let's get the give the programmer the capability of writing agents in that language. So same with Jack. We think AI is gonna the AI is here to stay. So let's build these applications as if it's part of the language itself. Or in other words, give the AI first class citizenship within the programming language. So that's what we did with the by LLM keyword. So the by keyword allows you to annotate your code and say, okay, this is you can automate this using an LLM. So let's get into this tutorial. It's a short tutorial with bunch of like examples that you can look into. I'll link this link in the description as well as in the JacHacks Discord server. Join the server if you are already not on the server. So uh, yeah. So let's go into that tutorial in a sec. Let me set this and see if I can switch. Oh yeah, I can switch. Cool. Okay. Now, the first thing we should look at is the simple way to use the LLM, which is give it a bunch of stuff and get something out. So it's just you pass some information and the LLM generates string output and you get that string output. So that's how chatbots are built, right? So chatbots basically take in information, which is your prompt, and then it spits out the output strings and you get that string. So that's the most basic way you can interact with an LLM. And this is how you do it in JacLang. So this brainstorm idea is something to ground the LLM to something. So you can do that in other ways too. But this is the most simple way you can do the most less effort way of doing it, or yeah, the less effort way of doing it. So brainstorm 3 creative hackathon projects ideas with blah 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 blah. So let's see how this would look like in code. Yeah, you already saw that, but let's run it and see. So let's look at step one, which is uh, s- brainstorm ideas. So let me just drop the link to the tutorial right now. Give me a sec. Uh, uh, um, yeah, let me drop the tutorial. There you are. Copy. Okay, now let's go to this tutorial real quick. Okay, yeah. Okay, in this we have like 4 steps, simple steps to like let you see how these by LLM will be used. So it's a tutorial, but even though it's more of a demonstration of like how to build this. So step one, generate. So this is the thing that I just showed you, like the brainstorm ideas, and you have a text for grounding the LLM to like let the LLM know how to actually do the task well. And so this is so you basically define the function. You can add a sim string if you want to, and you just call it. So when you call the function, pass this interest and skills, and you'll get the ID, the output. So this skills is just a skills. It's not a skill file or anything. Just skills. So if you want to pass skill files, we can talk about it a little bit later. It's not covered in the tutorial code, but I'll show you like how you can do those kind of stuff. So you have brainstorm interest skills and so on. Okay, so this is the basic way to work this. So let me just check. So to install Jaseci, you can do a pip install. I'm just gonna just show you guys pip install. Yeah. Oh, just saw it. Oh, there you go. Pip install dash Jaseki, and it'll just install within your environment. And if you don't have even Python installed, still you just Jack has a simple way to do that. Let's just go to like installation and you grab the curl and that's it. So you have this curl command. So this one, yeah, just grab it and you're good to go. Just paste it here and can install it just like that. So Jack install, all good. Uh, Make sure to like refresh the terminal so it, otherwise like yeah. Yeah, refresh the terminal after you install. Just tip tips. Yeah. And to run this, you can just if it's a single Jack file and you don't have any front end written, you can run it as just Jack run, and just do this, and it will basically run. To let you a bit into like how the LLM's configured and everything, let me quickly go back to the documentation and walk you through that. So if you go to full reference AI integration by LLM reference, so the first thing anyone has to do is configure their LLM. However, we have a default configuration in by LLM itself. So let's say if you don't have an LLM, what will happen? So you have uh, let's say if you want to run your own like Olama model, uh, you can just pull like Olama and set this. So if you're running build the full stack application, you can just plugins by LM model under there, specify which model you want to, and that's basically how you set your model. And if you need vision capability, you can get that as well. So if you need, let me go to model config. Oh yeah. So if you want to change the model, just change the name. So the naming convention is basically through a light LLM's naming convention for models. So if you go to light LLM, light LLM. So if you go to light LLM, they have in their documentation, they have these providers, and each of these providers has a way to call, like specify the model. For an instance, let's say Anthropic. So in the Anthropic, it's pretty simple. It's just like you can just name it like this, or else if you want something like, let's say, AWS SageMaker. Now, after like setting everything, let me see the name. There you go. So model SageMaker, and you have to specify this, uh, like model like this, the way you define it. So just that each model can be defined in different ways in ByLLM too. So because ByLLM actually calls the LLM through Light LLM, so you can basically use Light LLM's own naming convention with ByLLM. Okay. So you have, let me go back to tutorial. Okay. So yeah, let me get down to model constructor. Yeah. So if you want to switch models, you just change the name. So this is basically how you can do it. However, you can also do it in a little bit different way as well. So I'll show it in the code. So if you want to specify a model in code itself, you can do that too. So let's say I want glob, sorry, for that, first import from byllm.lib, and you need to specify what you need to import, which is model. And yeah, and now you have the model. Let's create a model. So let's say glob, creating global variable. Let's call it, yeah, GPT-4o. Yeah, GPT-4o, 4o mini. Yeah, 4o mini. Okay, so you want to create a model called GPT-4o mini, and you say equals model GPT-4o mini. So that's basically it. So basically, this is setting the model name. So it's setting the model name as GPT-4 Mini for O Mini. There you go. Let's create this to O, yeah, O Mini. And now you have this GPT-4o Mini model in your code. Now, to use the model, you just use the name here. That's all. That's all you have to do. So with instead of by LLM, you can just do GPT-4o Mini there, and you are using the same now using this GPT-4o model. So I haven't so to get it working with a provider as any other SDK or any other way to reach the model, you need to have API key. So get the API key. You just need to like export. Just need to export your API key here, and let's say for OpenAI, you just do OpenAI API key, and that's it. So you can do OpenAI API key equals your key and put it into the environment and call it a day. So that's basically how you can call a model simple. So let's move on from this simple example and get deep into like more complex ones. Okay, so that's by LLM, simple, straightforward. Uh, and so the next thing, so this is this is another way. So this is generate. So I'm calling this the generate mechanism. So the way you can like generate stuff. Oh yeah, I split them. Okay, so you generate the output, simple. And the next thing is, yes, you still generate, but you can uh, do something smart with this. So that is, you define a type and let the LLM fill in the type using some information that's in the context. So if you want to extract something from the LLM, let's say you have a big PDF, you got the entire text, Now we want to extract the information about the author of the text, or else an information about who's the main protagonist, what's the the characterization, the character definition defining profile of this protagonist of this story. You just put in the story as a input parameter, as an input parameter for this structure, this function, and then you mention or annotate it with the type you want to get it as the output, and you get the output with the types, the values filled in. So this is like structured output. If you have worked with LLMs, you might like heard about like structured output generation, which is basically it outputs a JSON schema or else a pydantic type. So this is kind of the thing, but you are not doing any defining pydantic or defining the JSON schema. Everything is handled by the runtime. You just define a type in the language and use that to annotate your by-LLM call. So that's how you can use the extract functionality in JacHacks. So let's quickly look at the code. So you just have a type, you just call that type, and I'll just call Jack run, and you have step two to extract. So that's the second one. So extract, which is taking giving the LLM some context and taking an output, taking the output. But there's something also that's interesting that you can do with extract other than extracting information. That is giving the LLM the capability of choice. So in many cases, you might have seen code where you want to decide what the LLM wants to do. Let's say 5 decisions. Tell the LLM take one of the 5. But the way most people do it is you get the output, you match the string output. And if the LLM change the string by even by a letter, now you have a problem. What's the choice? It's ambiguous again. So this can be eliminated with by LLM using this functionality right here. I actually have it in the deck. So yeah. So what you can do is you can define an enum. Enum is the word for choice in a language. So you have an enum, you can have the same enum but different types within the enum. So you have the different choices within the enum. For example, if you have the personality type, it has three in this example, it has three possible choices: introvert, extrovert, ambivert. Now, if you define a bi-LLM function, outputting this personality or this enum as the type annotation, now you have choice. The LLM has choice. It can choose between these three choices that you predefine. So it cannot pick something else. It's always going to pick one of the three. So that's how you can use the language features itself, which has been there for like generations. You can use the language features itself to use the LLM, get the LLM to do the work. So choice is right there in the language itself. So that's is another fun capability and very important capability in Jack. Okay, in by LLM in within the Jack language. Now let's have a short pause. So so this is how you can build your applications using by LLM, where you call the LLM. This is a single. All of this is a single by LLM call so far. Now these are not agents per se because they don't have agency to do something, come back and think about it and go forward, or like just step back, have a look at it. All of those functionalities, the functionalities modern agents have, that's not existing within these abstractions so far. So let me show you how you can do that using BioLM itself, because it is in BioLM. That capability exists in BioLM. How do we use that? And also, how do we extend the capability of BioLM using the language features of Jack? So let's switch focus to agent orchestration. So earlier I told, okay, there are two challenges. One is prompt engineering, the other thing is agent orchestration. So how do we give the agent or the LLM the agency to do something? So there are many different patterns that exist within LLMs, like they do tool calling or they do something like sub-agent spawning. There's like a routing task, which is basically like looks like this. You can do a routing task like this, where you let the LLM have a choice and you manually run that in the code using using code. But that's still the LLM. LLM has a little bit of agency, but we can give more. So let's see how. So what the next thing that we have is the invoke capability of ByLLM, or in other words, the React functionality. So React is an established methodology for LLMs to reason, do something, come back, reason, do something, come back in a loop until you either get the job done or you hit a maximum cap. Now, this is the way you do it with with ByLLM, which is basically you do same by LLM. So this is simply the same functionality as generate, but now you have these tools within this by LLM. You can pass stuff to the LLM. So now you're passing these tools to the LLM, and these tools are just functions. These are just functions that exist. You just import them from somewhere, and you have this search at GitHub, describe tech stack, estimate build time. All of these you can just get them as like just get that and yeah, you can just like use like import these tools and just use them within by LLM. By LLM decides what these are by looking at these function names itself. Looking at this function itself decides what the LLM need to do. And if you want to enhance the LLM's capability of understanding what these tools are, add sem strings to the tools, because sem strings can be added to anything. It's not just a function. You can add it to any type, any field, any parameter of any function. You can add it anywhere, and the runtime decides what is important and sends that in. So in this case, if you had sem strings for like tools, that can be that is sent into the LLM to understand what this tool actually does. So let's move. So oh yeah, so I previously ran this structured pitch with input an app that matches blah blah, and it just gave this output. And step three, and in step three you have, yeah, step three is where you call the tools. So you have search GitHub, describe this tech stack, estimate build time. And let's quickly look at the tools, what they are. So they are import from tools. The tools are just a another file that has, yes, search GitHub. It's basically doing this. It's very simple. And then you have describe tech stack, which is a biLLM call, which is just a simple generate call. And you have estimate build time, again, a simple generate call. And then you have this save MD, like which allows the LLM to like save stuff to MD. And you add just sim strings to these. You just add sim strings to these new new stuff that you have. Like for search GitHub, you add this information, or search GitHub for open source projects matching a query, and so on and so on. So that's, you just add the sim strings and the LLM knows what this tool does. Okay, so that's that. So that's the tool. So let's just run that and see what it does. So step three, Jack run step three, step three. Yeah, that's the one. Okay, Jack run step three, and you'll see. Doo-doo-doo. So in the meantime, there's a bunch of repos. I'll show you guys. There's some repos that you can look into, see how these are actually built into front end, like full stack applications. We'll have a look at this by the end of this session. Oh yeah. So now with the invoke, you just have AI powered access. Like it's first talking about this. Um, yeah, with entry, research data. It's printing okay three invoke, and it's basically telling you what exactly it found out and the links and stuff. And you can see you have these GitHub links and so on. So those are searched on the internet, found out through using this tool. So you can, these tools can be called using, and you can get the tool outputs as well. So that's a streaming capability. I'll show you like the code that does this, a streaming capability in a bit. I'm not covering that in the tutorial, but it's in the reference, as well as the MCP server knows how to do that, as well as I'll show you, point you to some repos that actually does this. Now, yeah. Now let's move back and okay. So that's the loop. The agent decides what to do by itself. So the agents have information about how to interact with the environment. The tools are there. So it's trying to use the tools as best as it can to get your tasks done. So that's the tool calling capability within my LLM. Now, let's have a look at the next thing, which is routing. So this is a bit of a long thing to understand, big thing to understand. It's very simple, but introducing is it has always been a little bit tricky. Now, let's go with anyone who understand would be so this would be great if anyone wants to also understand object spatial programming, which is nodes, edges, and walkers in Jack. So it's not just about agentic. I'll switch back to how to do agentic with it. So let's move to our reference and get to oh yeah, go to get yeah, full reference. And I'll quickly go through. If you go to language specification, you can find these special programming. Okay, so Jack has functions, objects, basically a superset of Python. So it has everything for you to build it. But there's this special feature called object special programming, which basically give the code superpowers of having a structure with between a structure or a graph in your language. So let's get into how this works. So OSP has mainly three. So where OSP, like why ASP? So it's natural graph modeling. You can build your application as like a graph. If it fits, your application fits, you can build a graph right in the language. So it can do AI agent like architecture or orchestration. So it's also separates the concerns of data from behavior, where data can be abstracted away into a database through this object spatial programming, where each root of yeah, well, I'll get to the root in a bit. So now core concepts. So you have these few things that you have to understand: the node, the edge, the walker, the root, here, visitor. So the node itself is another type in the language, but it's a special type. It's called an archetype in the language. So this special type person is a node type, and also you can have edge types. So you have nodes and edges, and you can create a graph just by saying root Alice, and where Alice is a person object of type node. And you can connect Alice to another person, Bob, which is another person node, through this edge, which is nose. So you have this nose edge and it has an attribute too. So this is how you can build a graph using the language. You instantiate it, you build it, and you can filter out. You can query it too. I'll get into that in a bit. But there's another functionality. So here you see something called root. So a root is basically so there's a system root. When you just do a jack run, that's the system root. So whenever you do a jack run of a program, it'll always attach to the root of that session. But in when you're building full stack application with Jag, a root is a persistent object that is unique per each user. So each user that logs in has a particular root node. And whenever you connect some node to that root node in some fashion, doesn't have to be a direct connection. It can be like multi-hop connection. Sorry. So that multi-hop connection will basically let you connect things directly to the root, and that means they are persistent. So the graph itself becomes a database in Jack. So if you want to do databases in Jack, you just don't want have to because you just connect stuff to the root and it persists. So so building a graph basically means you are persisting to a database, and it is done in the local development server as well as in the deployment server. Like in a in a massive way. Like you have a MongoDB that's running on the server, you have a Redis cache that makes things faster, makes things faster for the for your full stack application and so on. So it's a you can full build your full application and do the deployment. So I'm stressing this out. I'm nerding on this because this is crazy. So okay, so we have the root per user, and per user you can create the graph. Simple. And to so this walker is the not the other feature that's very important, which is kind of an agent that can walk the graph. And the way this agent walk the graph is specified in code. Now in here you can see we say greet with root entry. So we whenever this walker is on the root node, so whenever is there is a whenever the walkers whenever the walker is on the root node, you just do a visit. And on the root node, this function says this is called an ability in the language. So if you have a ability as a greet, you have this ability as greet, and with root entry you do a visit. So the visit means you are going to visit your outgoing nodes, right? This means just all the outgoing nodes from the current node. And then you have, when you visit the outgoing nodes, which are this person node, you can see they are outgoing nodes. And when you connect it to the outgoing node, uh, yeah. So you have, yeah, say hello with person with entry, and then you say print hello here.name. So we have a new thing. What is here? We know self. In these languages we had self all the time. Self means self-referential pointer, kind of pointing to the self object. So if you are a if you are defined if you are used within a type, you can reference the type itself or the instance of that type itself. This is kind of the same but a little different. What this means is whenever the walker self is there, self means walker, and here means the node the walker is currently on. So that's the thing here. So whenever the root is on a specific node, that node can be referred through here, and that node's attributes can be accessed through here. And on the contrary, on the node, you can say, what does my visitor have? And you can use the visitor keyword. So that's what we saw here. So you can use the visitor keyword to see what's on the walker from the node's perspective, and you can use here from the walker's perspective what's on the node. So these are the constructs that's there that basically gives you the object spatial programming, where you have a graph and you can program a walker to walk a graph to do something. So what makes this interesting for agentic AI is right now this is hard-coded code within each of these bodies. Instead, why can't we have AI applications, AI functionality built into the body? So that's how you can do agentic AI with OSP. So you can basically build your agent in an architecture where the walker is the agent. You call the walker, and the walker decides how it walks because we build the AI functionality within the body itself. That's why I said we can enhance the capability of BioLLM using this capability. Okay, now why? Because we already talked about tools. So an agent is basically an LLM attached with a bunch of tools, right? That's not exactly true. So when you build your agents, if you build your agent in a way where all the tools are attached to the LLM and available all the time, that's going to be difficult because the LLM has too much context. Sometimes, it has too many tools, too many options, and it might do something that we do not intend, and it might not follow some instruction. So what we can do with OSP is we can bring out some of that capability from that single monolithic AI agent, which we can break it down to smaller agents and do sub agent spawning and so on. So the AI decides what to do, and how it's done is through another OSP, using a more structured application. So it's not just building your agent by slapping on a bunch of tools with a skill file on an LLM. It's more about how you manage the context so that the LLM does the right thing, not the wrong thing. Uh, and there's also the realm of optimizing for tokens. We'll not go into that right now. Okay. Now, the next thing, oh, so yeah, let's go into the code and see how this is built with OSP. So now we have a functionality. The idea is with entry, I'll look at this first. So with entry, so you have this advisor node that is spawned on this hackathon advisor to this root. And then you have a pitch, which is a real-time multiplayer trivia game with AI generated questions using WebSockets and React. So you want to build this. This is not nothing with Jack. This is something like that you want to build. Now, in the application, you can just say just root spawn. That means this is spawned, and this advisor will basically return the hackathon advisor object after everything's done. So it will return back, okay, what's the hackathon advisor, and it will just print out what the hackathon advisor returns. Okay, now let's look at the hackathon advisor. So the hackathon advisor has like a pitch, the task, the mentor, the result, and has the route. So it has these few agents or sub agents, kind of, which is web developer mentor, mobile mentor, AI mentor, game developer mentor. So if you have finalized your like task, these agents are going to tell you how you can build for this realm, like for AI agents, how you build that, game dev mentor, how you do that. Now, so you have visit. So at the end, you have this special capability in MyLLM, another special capability. This is called visit the set of nodes by LLM. So this semantics mean that the outgoing nodes that previously visited are now LLM decides. The LLM decides which of the outgoing nodes to visit, and we give it the context about the pitch, what we need to accomplish here, right here. Okay, did I mess something up? Oh no, cool. So you have, yeah, let me just go back to Hackathon Advisor. Okay, so you have the Hackathon Advisor, and it'll basically do visit by LLM, and it'll visit the nodes that are important, which nodes that are important, and it'll bring back stuff. However, what's another cool feature is you can spawn subagents through this. So we don't want each of them to like complete independently. We can get everyone's information all at once. So what we do is, so this is when you spawn them, and now this is what happens when you collect them. So basically look at the tasks, get the information, and just consolidate the final answer. But the nice feature is right here in each of these mobile mentor, AI mentor, and game development mentor. So if you look at mobile, let's say look at web development mentor, you can see that we use this flow keyword. So T equals flow root spawn advice walker. So you have an advice worker, which is another walker. So if you go up, so this is another walker, and it has with root entry, self advise, get advice. So it calls it get advice function, which is again another binary call. Now, what happens here is it will, whenever it is in each of these like mentors, what will happen is you have web development mentor, and you do roots spawn advice mentor, this advice mentor, advice mentor, and the advice mentor will just go in and just do the task on this route itself and come back. So you route spawn this, and it'll come back, and it'll be this T. And what flow is, the way you can spawn walkers in a concurrent way. All these walkers you are spawning concurrently. So you spawn this walker, you get this pointer to that walker, and now you have another walker spawn here. You have another walker spawn here. All of them are concurrent. So you visit all of the nodes that are important, but on each node you are spawning something with non-blocking. You spawn something, you get the reference to that process, you go to the next one, you keep accumulating these references, and you just at the end just yeah, and at the end, after everything's done, you keep accumulating stuff, and then you come to collect node, and then you get uh, with collect node, yeah, you do w wait self tasks. So basically, you wait for each of the tasks, and when it's done, cool. So you can wait for all of the tasks, and in any way that you feel best, and then you do the final result because you have to wait for everything else. Okay, now we can do this. This is how you can do like concurrent walker spawning, and also this capability of doing async walkers, async functions, async walkers. All of these are documented in the documentation. For the time being, I'm gonna just run this application right here. So it's gonna take a little bit while because it's a bunch of walkers and do jack run step 4 route. Oops, my bad. Now, while this is running, we build this so these are individual. Oh, my bad. You're already done. Sorry. So we have the web dev, you have the X mobile, you have the game dev. Everybody's like giving 5 tips for each of the thing because we defined it as okay, give 5 tips for each. So it's giving you these information out. And okay, so that's basically how you can get tasks done using OSP, and where you can do like multiple where you can orchestrate the LLM. So you basically need to go through how OSP can be used. You can follow the tutorials that's available, and in the body decide what you put in terms of by LLM or agentic behavior. Okay, now you have one. I went through 1 to 4, and those are individual calls to the LLM, individual functionalities. How do we put this together? So that's also available in the repo. You just need to go to app.jack, and that's the entire application right there. But it is tagged with a front end, which is the nice thing. So now it has this front end, which is app.cl. So you can just go to this app.jack, and you can do a jack start instead. Whenever you want to start your or begin your or like start your dev server for uh, a front end, a full stack application, or a backend application, you do jack start. LLMs might hallucinate it and say jack serve. That's the old way of doing things. Tell it to do jack start instead, and point it to the MCP server or the skill files, and it'll know how to run these anyways. So jack start app.jack. Okay, now what will this give us? Building client model. Okay, there you go. Ah, now this is a very simple, no user, no authentication is here, nothing's here. You can just build in the authentication. It's just making these functions uh, just public to private, and you call it a day. And you can basically make the all of these like authenticated per user, sessioned out, all of this capability. But I just want to build this so you guys can see what can be done. So quickly within the next 6 minutes that's available, I'll just quickly say, okay, I'm interested in music and composing, and I am a Python Jack, let's say Jack JS, and so on. So you brainstorm ideas, and it'll get back. Okay, you have that info. You put that into here. Oh wait, I have to choose one. My bad. You have melody mixer, rhythm recommender. Melody mixer sounds fine. Get that one. You put it down here. Structured pitch. It'll give you how to like structure your pitch about this, like a melody mixer, the problem, the solution. The wow factor of this, users can create and share their compositions instantly with a community feature that allows collaboration and feedback among music enthusiasts. Cool. That sounds cool. Now let's use this in the next phase, which is invoke. Do some research, come back, tell me, have people done this? How can this be done? Like, what's the way to do this? So it's doing a research. That means it's doing a bunch of tool calls. is going to, you can see it happening right here, to be honest. So you can see it's doing a call to the LLM, coming back, it's doing something else, coming back. So whenever there's a call, you'll see this lightly LLM completion, which is basically going through light LLM. And whoop, I think it finished. Yeah. So now you have a nice MD file formatted description about how you can do this and the other examples. So you have these GitHub pages that you can just click and go to. Oh, I forgot about that because it's not multi-user. Now I have to go from the start. Okay. I won't do that again. So uh, so you basically get this research and you do get mentor advice, which is basically the same thing that I did like just before, which is spawn everything, get back, and report, basically report each and everyone's advice on how to build this application. Okay. Now, because of we have like just like 2 minutes left or 4 minutes left, uh, I just want to show you guys some repos that you can go to. So if you go to Jaseci, let me just see. Yeah. Oh yeah. If you go to, so if you can see a bunch of examples in like you can just go to Jaseki, uh, the repo, and go to the organization, and you might see applications like Agentic AI. Now that's a good place to look at because it has a bunch of these applications that are built with including my LLM and also streaming outputs to a front end. So you can, there are a lot of like very good examples like the JacGPT full stack, and you have the uh, yeah, you have Ada Genius, Travel Planner, Friend Zone. There's a bunch of applications with which is which are full stack applications. So that's a nice report to look at, as well as give me a second. I think we have posted this information in the general as well about like these. Yeah, I think I posted this in general in JacHacks. Um, let's see. Oh yeah, there you go. So you have this Agentic AI, and then you have Jack MCP Playground. That's another nice link that you can use here. This, for some reason, it's my links are going everywhere. Yeah. So you have this repo, which is Jack MCP Playground. This is built by amazing people like Sahan and Udit, and you have these guys building these wonderful applications. You see, this is a full stack application build. This is not. I think this does not have YLLM, but this is a full stack application, a very good example to look at. But the Agentic AI repo has a bunch of Agentic AI applications built. You can use that architecture, and also we have another one called Algo. Let me just hit that link and just put it here. Ah, there you go. Oh yeah, you can actually go to build with Jaseki, and there's a bunch of other applications people built for previous hackathons as well as for a class, which are actually deployed. Like if you look at this Maze Mine, that's gonna like blow your mind because you can brainstorm very well with Maze Mine. So check it out, and you have GitHub and so on. So you have a bunch of applications here. Use these resources, look at these repos, point your LLMs to look at the repos, or your agents to look at the repos, and understand them and use this architecture for building your applications. Okay, now next thing that we'll be doing for the hackathon is a quick meetup with anyone who needs help. You can just join in the mid like checkpoint. So if you are stuck in anything, installation or something, just hop onto the Zoom call. I think the link is in the Jack Hacks Discord. So go there, click the link, join the Zoom link, and we'll meet there. Cool. I think with that, I'm gonna end the hack in end the stream. Thank you all for joining for the Agentic AI tutorial, and hope you guys a wonderful journey through this hackathon as well as beyond. With and keep using Jag because this is gonna be the next big thing in Agentic AI, full stack application development, programming in general. So see you again in the download.